In this video, we are going to discuss about some important objective question from the chapter DNA block elements, class 12. So this is the first question. The electronic configuration of copper 2 plus is 3d9, whereas that of copper 1 is 3d10. Which one of the following is correct? Copper 2 is more stable, copper 2 is less stable, copper 1 and copper 2 are equally stable. Stability of copper 1 and 2 depends on nature of the salt. So this question is basically deals with the charge by area of the ion, copper ion. Here the charge by area for the copper 2 plus is more as compared to copper 1. So option 1 is our correct option, because more the charge by area, more easily it can attract the anion. So option A is your correct answer. So the second question is electronic configuration of transition element X in +3 oxidation state is this. What is the atomic number? So in this configuration we have to add 3 more electron to get the atomic number. We know that argon is 18, so 18 plus 5 is 23, plus 3 you add, you'll get 26. 26 is the atomic number. That means they are discussing about iron. So option B is the correct option. Next, question number 3. In question number 3, it says when KMnO4 solution is added to oxalic acid, means KMnO4 in acidic medium, the decolorization is slow in the beginning but becomes instantaneous after some time. It is because we know that KMnO4 in acidic medium converts into Mn+2, which will act as an autocatalyst for the further reaction. So that's why option D is the correct option. When acidified K2Cl2O7 solution is added to Sn salt, then Sn+2. So we know that K2Cl2O7 is an oxidizing agent, so Sn+2 will oxidize into Sn+4. So option C is the correct option. Question 5. In 5, which of the following is diamagnetic ion? Atomic number is given. So in order to find the diamagnetic ion, you have to find that element having no unpaired electron. No unpaired electron. If you do it carefully, you will know that scandium, in scandium +3, there will be no unpaired electron in D or S. So option B is the correct option. Next, which set of ions exhibit specific colors? So in order to show colors, the element should contain unpaired electron. So if you write the electronic configuration for the options that are given, you will get to know that option C, this option C, P3 plus P2 plus Fe3 plus, it will have unpaired electron. Clearly you can say in Fe3 plus iron 3 plus, you will have 3d5 configuration. So you will have unpaired electron. In P2 plus also you will have unpaired electron. In P3 plus also you will have unpaired electron. So option C is the correct option. Next, question number 7. In question number 7, KMnO4 is colored due to. So remember, KMnO4 is colored. It is because of charge transfer from the ligand to metal. So that's why KMnO4 is colored. Other than that, KMnO4 is not colored because of the DD transition, because in KMnO4 manganese is in +7 oxidation state. So +7 means there is no electron in Mn in the valence shell, no unpaired electron in the valence shell of Mn. So it cannot be DD transition. It is because of the charge transfer from the ligand, that is oxygen, towards the metal, means Mn. So option B is the correct option. Next question is, which of the following statement is not correct? So which one is not correct? So if you carefully observe, it is written option C, LaOH3 is less basic than LuOH3. That means lanthanum hydroxide is less basic than lutetium hydroxide, which is actually wrong, because we know that as we go from left to right in lanthanide series, the basicity decreases. So obviously this option C is wrong. Lanthanide contraction is caused due to, it is because of option D, poor shielding of 4f electrons. In which of the following elements 5f orbitals are progressively filled? It is actinoids. Gadolinium belongs to 4f series. Its atomic number is 64. Which of the following is correct electronic configuration? So you have to memorize the configuration. For gadolinium, you have to remember that 4f is half filled. So option A is the correct option, because only in option A we have 4f half filled, that is 4f7 configuration. Next question is assertion reasoning type questions. Here assertion is the highest oxidation state of osmium is +8, which is correct. Osmium is a 5d block orbital. This option A is correct, but R is not the correct reason for this. So we have both A and R are true, but R, the reason is not the correct option, correct answer for the assertion. So obviously B will be the correct option. Next, transition metals have low melting point, and reason the involvement of greater number of n-1d and ns electrons in the interatomic metallic bonding. So we know that transition metals have very high melting points. So option A means assertion is wrong, but R reason is correct because this is the correct explanation for the high melting point of transition metals. So option D is correct option because A is assertion is wrong, but reason is correct. Next, number 3. In 3, transition metals have high melting point. That is correct. Transition metals have completely filled d orbitals. Is wrong. This R is wrong. So obviously for question number 3, option C is the correct option. A is true, R is false. A is true, R is false. Next, number 4. Chromium is an actinoid, which is wrong. In chromium, 3d orbitals are filled. That is correct. That means A is wrong, R is correct. Next, number 5. Chemistry of actinoid is more complicated than anthanoids. Actinoid elements are radioactive in nature. So if you carefully observe, you will see that both the A and R are correct. Means actinoids are very complicated as compared to lanthanoids, and actinoid elements are mostly radioactive. That is also correct, but these two are not the perfect. They are not. A reason is not the correct explanation for assertion. So obviously option B will be the correct option. Means reason A and R both are true, but reason is not the correct explanation for assertion. So obviously this is how you will attempt the questions.